Hello, my dear students. I am P. Madhara, lecturer in physics in continuation of video lectures. Today we will discuss about capacitors. So in this capacitors, first we have the simple formulas. Few formulas we have got. First one is when capacitors connected in series, we have got 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. When capacitors are connected in parallel, you got C is equal to C1 plus C2 plus C3. Now, again, second formula is C is equal to epsilon naught A by D. When you consider a capacitor here, like this, you got two plates here. A is the area of the plates, D is the distance between the plates. Area we take it as a medium, then C is equal to epsilon naught A by D. Now, another formula is, suppose you keep a dielectric of thickness T in between the plates, then D is the distance between the plates, K is a dielectric constant for that particular material, then we have got epsilon naught A by D minus T by K is the formula. Now energy stored in a capacitor is given by three formulas. One is Q square by 2C, half CV square and half QV. So depending on the situation, we are going to use these formulas. So when a capacitor is charged means you have to use this formula Q square by 2C. And again, you have got a capacitance C, V is the potential, then half CV square you have to use. When you have the Q charge and potential, no, half QV you should use. Then loss of energy. When you have loss of energy means you have one capacitor, another uncharged capacitor is connected, and total energy, loss of energy of the system you want to calculate. Then you have the formula half into C1 C2 by C1 plus C2 into V1 minus V2 whole square. That is the loss of energy formula. Then again common potential, like this, one capacitor is there, other capacitor is there. There one is charged, other is uncharged. Then you have got common potential. Then your formula C1 V1 plus C2 V2 by C1 plus C2. So these are the few formulas we are going to use in these problems. Now, so the very first problem. First problem is here a parallel plate capacitor of 40 centimeters square and plate separation is 2 millimeters. Plate separation 2 millimeters. The space between them filled by a dielectric medium of thickness 1 millimeter and dielectric constant K is 5. Then find capacitance. I've got options here. First option 24 epsilon naught farads directly. Second, next 3 by 10 epsilon naught F. 3 10 by 3 epsilon naught F. Fourth one is 10 epsilon naught F. So you got direct formula C is equal to epsilon naught A by D minus T plus T by K you got. So C is equal to epsilon naught A, how much here? 40 square centimeters. Convert in square meters. You know 1 centimeter is 10 to the power of minus 2 meters. Square centimeter 10 to the power of minus 4. Now again distance between the plates, how much here? 2 millimeters. So 2 into 10 to the power of minus 3 minus thickness is 1 millimeter here given, 1 into 10 to the power of minus 3 plus what is the thickness again, 1 millimeter. Again what is the value, 5 you got, this is 5. Now here if you simplify, C is equal to 4 into 10 to the power of minus 3 you got here. This is 2 minus 1, 1. 1 plus 1 by 5 into 10 to the power of minus 3. This minus 3 get cancelled. So here how much you got here? Here if you take LCM here, epsilon naught 4 by, this is a 5 plus 1, 6. So again C is equal to epsilon naught 4 into 6 into 5. 2 2s are 2 3s are. So 10 epsilon naught by 3. 10 epsilon naught by 3 is the option. So third option is correct. See this problem once again. C is equal to epsilon naught A by D, D minus T plus T by K you have. In this all electrical units are measured in MK system. MK system means you convert, whether millimeter, centimeter, all should be made into one system. So in that case 1 centimeter is equal to 10 power minus 2 meters. So I convert it into square meters. Okay. Now here this millimeters converted to meters, millimeter converted to meters here. So again I took common here, 10 power minus 3, here minus 3, 1 0 getting cancelled here, 4 into 10 power minus 3, minus 3 cancel. So I took LCM here, epsilon naught 4 by 6 by 5. So this 5 goes to numerator, 5 by 6, 10 epsilon naught 3, 10 epsilon naught by 3 is the option. Okay. Now this is dielectric. Suppose if you take a metal plate, instead of this capacitor, instead of keeping dielectric, if you keep metal plate, no? So for metal plate, dielectric constant is infinity. Do remember this, important. So all the time we do problems with dielectric only. But if you keep metal plate, no, K is infinity. Okay. So K become infinity means what here? 1 by infinity becomes 0. So the formula modifies here. Suppose if we keep a metal plate, no, it will be D minus T. This is a formula. So if K is this in between the plates, if metal plate is kept, metal plate placed between the plates of the capacitor, then you have got epsilon naught by D minus T. This is the formula. Our next question now. Next question is, what? Directly you have got loss of energy formula. Same model. A capacitance of capacitor, a capacitor of capacitance five microfarads, they are separated by air, and distance is D. A slab of material, dielectric material of K, dielectric constant 1.5, having equal area to that of the plates, to that of the plates, and thickness is d by 2. Thickness d by 2 placed between the plates. Placed between the plates. Then the capacitance of the capacitor will be of capacitor. We go for normal formula here. C is equal to epsilon naught A by d minus t plus t by k. You have that formula. So initially, what is the capacitance? C is equal to epsilon naught A by d now. This you got 5 microfarads. 5 microfarads given already. So here you take epsilon naught A by d minus equal to, here how much you got thickness d by 2 by d by 2 into 1.5. K value 1.5 now. So here epsilon naught A by d minus to d by 2 means d by 2 only, plus d by 3 you will get. Now if you take LCM now, here how much will be? Epsilon naught A, here take LCM 6 here down, 3d plus 2d I got. Now again C is equal to, if you write here like this, 6 epsilon naught A by 5d. But already you got how much? Epsilon naught A by d how much? 5 now. 6 by 5 into 5. How much? 6 microfarads is the answer. You followed now? Directly what we are doing, thickness is d by 2 and t is d by 2 I substituted 2 into 1.5 epsilon naught A by d by 2 plus d by 3. I took LCM here 6 3d plus 2d you got. Okay. Then here 2d plus 3d, no problem. 2d plus 3d you got. That added up here 6 epsilon naught A by 5d. Epsilon naught A by d already you got 5 microfarads. Cancel out, you will get 6 microfarads. This is the second problem. Simple situation. You have to work out like this. Okay. Now, see this formula very, very important. Next, another problem. Problem 3. A 6 picofarads. 600 picofarad means, pico means 10 to the power of minus 12. Okay. Micro means 10 to the power of minus 6. Do remember this conversion is important. A 600 picofarad capacitor is charged to 200 volts. 200 volts supply, and then it is disconnected. It is disconnected from the supply, again connected to another uncharged 600 picofarad capacitor. Then find loss of energy lost, loss of electrostatic energy. So loss of energy, common potential can calculate and do it. Otherwise, direct situation here, half C1 C2 by C1 plus C2 into V1 minus V2 whole square. So what is C1 C2? You got here half into 600 into 600 picofarad. You know picofarad 10 power minus 12 into minus 12 you do divided by 600. So how much? 1200 10 to the power of minus 12. So here situation is first capacitor connected like this charged. Now again after charging this is getting disconnected. Again you are connecting like this, same equal capacitors, like same model. So here capacitance same only. Then this loss of energy, this uncharged, no? Uncharged. So here V1 minus V1 is how much you got here? 200 volts. Other one is uncharged, no? 0. So 200 minus 0 whole square you do. So this goes how many times? 2 times here. The minus 12 cancel. 1 by 4 you got here. 600 into 200 into 200. Okay. So again 10 to the power of minus 12 you got here. 1, 2, 3, 6 zeros getting cancelled. 6 to the 12, 12 to the 24. 24 by 4 into 10 to the power of minus 6. So how much you get here? 6 microjoules you get. 6 microjoules. 10 to the power of minus 6 means micro. Remember all the time, 10 to the power of minus 6 is microjoules. Got it now? This is the formula, direct formula, and substitute. This is the situation we have done it here. Okay? This is loss of energy U is given by 6 microjoules. Okay? And next, then some simple circuits will be given in exam. There will be, you have to follow polarity, positive, negative, like that. So in that case, if polarity not followed, then that capacitor will be short circuited. So one situation like that we have. Now, fourth problem. Now, find the equivalent capacitance between A and B of the following combination. So quite tricky question this one. So you need to understand this concept and you have to work out. Okay. All are having equal capacitance. Okay. C, A and B. Suppose if you take positive polarity here, negative polarity here, what happens? Positive, negative, positive, negative. Again what happens, one positive, one negative like this. So here this polarity is not following. Here positive, negative, positive. These two are short circuited. Polarity not following, here two terminals. So these two are short circuited. That is, suppose you take 2 and 3. This first combination will take 1, 2, 3, 4 will take. 1, 2 will be there. 3 and 4 are short circuited. So this you have to neglect. Then in that case, what is the effective capacitance? A and B, no? These two are parallel, no? Options are here. C, 2C, C by 2, D, 4C. So these two are parallel, 2C option is correct. These two are short circuited. You have followed? So this is the tricky question, very, very important. Okay? Polarity not followed here, so therefore they are short circuited. Now, next, the problem. In the given figure, in the given figure, the total charge stored is 100 microcoulombs. Then the value of x is, we'll draw a diagram here. There are 3 capacitors are there here like this. Should be equal. C1, C2, C3, each having 2 microfarad capacitors. Sorry, this is X microfarads. C3 is 3 microfarads. Okay. This potential difference across this is 10 volts. Okay. Now, in parallel combination, what is constant? Potential is constant. V is same. In parallel combination, V is same. And in the case of capacitor, what you find? You find charge, no? So they differ in charges. Okay. They differ in charges. So what is the total charge you given it as? 100 microcoulombs. So what you need to write here? Q is equal to Q1 plus Q2 plus Q3. Somewhere it is like this down. Total charge getting distributed. If we have battery here like this down, if you draw like this now, then this is total charge given already. Total charge how much given? 100 microcoulombs is equal to Q1 is equal to C1 V1. Q1 is equal to C1V. Q2 is equal to C2V. Q3 is equal to C3V, right? So V remains same, 10 volts only, no? So 10 into 2 plus second one X into 10. 10 into X will write. 10 into X, second one. Third one, 10 into 3. Since all are microfarads, no? You need not convert anything, directly you can go for it. So here 20 plus 30 is equal to 10x. So here 100 minus 50 is equal to 10x. X is equal to 100 by 50. 50 by 10. That is how much? 5 microfarads. 5 microfarads is the X is 5 microfarads is the answer. So these are some selective problems we did here in the capacitors. Do practice once they model these model problems. Very important for JEE Mains. Thank you.